Hello everyone, welcome to our tutorials on mechanics of fluids, and in this video lecture I am going to explain about total pressure force and the center of pressure, and which is related to the hydrostatic forces on a given object which is submerged in the fluid. Okay, so in that we have to discuss about the total pressure force and the center of pressure. So now I would like to explain that. So first we have to know what is the hydrostatic force and what is the conditions we can consider whenever the fluid is static. So hydrostatic force can be defined as a force which is exerted by a static fluid on any object which is submerged or immersed in the fluid. Okay, now force exerted by the fluid, here the hydrostatic means here we need to consider the water here. So whenever we insert any object in a water, that means immerse that object in the water. So whatever the force applied by that water due to the pressure over the body is called as here hydrostatic force. And in static fluid, so the conditions we have to know when we consider a static fluid. So one first condition we can consider that velocity gradient is zero as the fluid is under static condition. So whenever the fluid is under stationary condition, that means there is no movement from one place to another place for the fluid. So automatically there will be no relative motion between the two adjacent layers of the fluid particles. So in that condition we can say that the velocity gradient can be zero, which is du by dy. And similarly we can say that shear stress in between the two adjacent layers of the fluid is zero. So whatever we are considering the velocity gradient is zero means automatically, and again there is no relative motion in between the two adjacent layer means automatically the shear stress between the two adjacent layers becomes zero again. Okay, and one more thing is, so whatever the force that can be exerted by the fluid on its surrounding walls and the base, which is called as hydrostatic force. So once again I've defined the hydrostatic force here. So that is the force which is due to the pressure applied by the fluid on its surrounding walls and the base where it is lying, or assume it is in a container. So the force applied by that liquid or fluid is called as here hydrostatic force. So basically while studying about the hydrostatic force, mainly two things we need to study carefully. So what are the two things here? So here I would like to say, in hydrostatic force analysis one should have a knowledge of, first thing is total pressure force, how much the total pressure force is acting on a particular object or plane surface you are inserting into the fluid here. And similarly the center of pressure, so where that total pressure is exactly acting. So basically pressure means it is the surface force which is acting, and we have to know what is the total force is acting. And whenever we consider the liquid, the pressure will be increasing from free surface to the bottom surface. So in that condition, wherever the maximum force is acting, that we have to know. So that is related to the total force here. And similarly where it is acting, that is center of the pressure, that is related to the total pressure where it is acting. Okay, and similarly I would like to take an example here. So assume in a container or whatever it is, a water is taking place, that is the static. In a container we can consider a static fluid, or here consider the water, so inside which I would like to place a vertical plate here. So when we insert a vertical plate, the water particles will try to apply the force over the plane surface of the body on both sides here. So like this the force acts over the plane surface of the plate. So whatever the force this is acting, as per our knowledge up to now, we can say that the pressure force, which is the pressure force which will be increasing when you are going downward. So according to the hydrostatic law, we can say that pressure is equal to rho g h. It depends upon the height. Okay, so that is related to the depth of the water or fluid here. So when you are going downwards, the force will be increasing. Okay, that is later here. But here when we insert a plate into the water, the pressure force acts, that is the force hydrostatic force, which is due to the pressure only here. Okay, and in this again we have to know what is the maximum force. Okay, maximum force may be acting at a particular point, okay, which is due to the pressure. Again here we are saying when you are going downward direction, the pressure may be increasing. Okay, so did that pressure increase at a particular point, not at the middle position of the plate. So other than the center position of the plate, the total pressure will be acting at a particular position. So assume this is the point here where the total pressure force will be acting here. Okay, that is the hydrostatic force. Okay, so this line I am representing as a total pressure force, and the point of application is the center of pressure here. So that means here the total pressure force means we can define. How can we define the total pressure force? Means here it is the total force exerted by a fluid on a given plate, that may be a vertical plate or inclined plate or a curved plate, when the fluid comes in contact with the liquid. Sorry, here it is not plain here, so try to make the correction here. When it comes in contact with the fluid, okay, so that is the total pressure force. And similarly, how can we define a center of pressure? The center of pressure can be defined as it is a point where the total pressure force acts on the plate. So point of application of the total pressure force on the plate in any direction we can consider. Both sides the point will be same only. So that point of application of the total pressure force is called as a center of pressure. Okay, so to analyze these two, again there are different cases are there. Okay, every time when you are inserting an object, that is the plate here we are considering in a liquid, there are some cases there to analyze the total pressure force and the center of pressure. So what are the cases here we can consider means, so the following are the cases considered to find the total pressure force and the center of pressure on a submerged plate in a fluid. So following cases means, first one is vertical plate. So whenever we are inserting the plate that is in vertical condition, so what is the total pressure force and what is the center of pressure we need to find. And similarly, when it is inclined plate, the plate is inclined at a particular angle, okay, with respect to a particular base here. So in that condition also we have to know what is the total pressure force and what is the center of pressure. And similarly, third and last case is the curved plate. Okay, so based upon the shape of the object we are inserting into the water or liquid or fluid here, so there are different cases are there. So for each and every case we have to know what is the total pressure value and what is the center of pressure, that is the position of the total pressure here we have to know. So now in this video I would like to explain about the vertical plate here. So vertical plate is submerged in a liquid. So assume this is a liquid in a container. I'm placing a plate. So as usually we know the pressure force acts over it, okay, and we need to find the total pressure force and the center of pressure, the location of the total pressure here. So for that I would like to take the side view of the object. So assume a random shape of a plate is inserted, oval shape of the plate is inserted in a vertical position into the water here. So to derive the expression for the total pressure force, we have to assume an elemental area, elemental strip. Okay, I'm assuming an elemental strip here which is of height dh, small dh, and of width b, okay, b wide. And similarly the location of this strip from the free surface of the liquid I'm assuming as h. And similarly I would like to assume the center of gravity of the object which is again at a distance of h bar from the free surface of the liquid. Here we are taking the reference of free surface. So from that we can find out the what is the total pressure force and what is the center of pressure here. Okay, these are the assumptions, elements required to derive an expression for the two things. One is total pressure force and second one is center of pressure here. So now I would like to take the help of this diagram, and next I would like to write the pressure acting on a strip or any surface. We can write the formula for the pressure as from the hydrostatic law as rho g h. Okay, this is the formula everyone know. That is the pressure is equal to rho g h. And at the same time the pressure we have another formula which is the force acting per unit area here. Okay, so force is equal to, again we can write it as pressure into area. Okay, here this is the total force here, but here we have taken elemental strip. So on that element what is the small force is acting, that is equal to, we can write it as pressure into smaller area. Okay, the pressure will be same at any point you select because it is a surface force. Okay, now so that P as it is we have to write, but elemental area we need to consider for elemental force here. And similarly P is equal to what we can write from the hydrostatic law, whatever the formula we know, we can write rho g h into dA. Okay, in place of dA again we can write it as B into dH. Okay, the area of the elemental strip we can write it as width into height, that is dH, B into dH we can write. Okay, so that is the elemental force. When you want to write the total pressure force on the plate, we need to integrate the equation. So integration of dF. Okay, so integration of dF will give you the total pressure force on the plate here, and that is equal to, again in place of dF write down whatever the formula we got here, rho g h into B into dH. Okay, and in this rho g are two constants. We can take the common of rho g. Okay, rho g of integration h into b into dh, we can write it as b into dh. Okay, so in the next step we can modify the equation like rho g of integration of b into dh. Again, what we can write it as b into dh as dA. Okay, when you keenly observe this integration h dA, this is the moment of the area. So this moment of the area will give you the center of gravity position of the given object. So from the MYS mechanics of solids, this integration h dA, we can write it as center of gravity position. The formula is given as the total pressure force on the plate is equal to rho g A into h bar. Okay, so elemental area becomes total area, and the h value becomes here the distance of the center of gravity of the given object from the reference position. Here we have taken the free surface of the liquid. Okay, this is the equation for the total pressure force on the plate. To find the value of total pressure force on the plate, this is the formula rho g Ah bar we can consider here. Okay, so remember this formula, very important for finding the total pressure force on the vertical plate. Next we go for finding center of pressure. So assume here the center of pressure is acting at a distance of h bar from the free surface. Okay, when you are assuming this h bar, that is the location of the center of pressure from the free surface we are assuming, and here by considering the moment of principle, we can write here, we can derive the equation. So for that, try to write moment of the total pressure force is equal to total pressure force, that is the location of the pressure we have assumed as a distance as h star here. So that force, total force F into h star, we can write as a total moment of the total pressure force. And similarly, try to write, okay, assume this equation as one, and try to write moment of elemental force on strip, elemental force on the strip. So whatever the element we have considered, there is a pressure force is acting. So try to take the moment with respect to the free surface only for the elemental force. That can be written as dF into, what is the distance here, h we have considered. So dh into h we can write, and again in place of df we can write it as rho g h into dA. Okay, so again forgetting that here rho g h into dA is the df, and h as it is we have to write here. So again forgetting the moment, okay, here by multiplying h and h we can write it as h square into dA. Okay, and similarly if you want to write moment of the total force on the plate, again we have to integrate the equation. So integrate rho g h square into dA. Okay, again take rho g as common, then we can write it as h square dA. So when you this one keenly observe, so I'll tell you later. So first when you keenly observe this one, again this becomes moment of the area. Moment of area means it becomes a moment of inertia with respect to the reference position here. So that can be written as I naught here, rho g I naught. Okay, so assume this equation as 2. So when you observe these two equations, moment of the total pressure force, moment of total force on the plate, both are same only. So this becomes 1 is equal to 2. So when you apply 1 is equal to, it becomes F into h star into rho g I naught. Okay, so in this condition we have to know h star, which is the location of the center of pressure from the free surface here. So h star is equal to, we can write it as rho g I naught by F. So again F is equal to, we can write it as total pressure force, that is rho g A h bar. So this is the equation we got for the total pressure force. So rho g gets cancels here. So remaining equation we can write I naught by AH bar. Okay, here AH bar line is not not here. Try to consider H bar here. And from the theorem of parallel axis, we can write again I naught is equal to Ig plus AH bar square. So I naught is equal to, we can substitute, this equation is again obtained from the MYS mechanics of solids. Try to go through the topic again. So finally we can write h star is equal to, in place of I naught, Ig plus AH bar square by, we can write AH bar here. So when you separately write h bar, AH bar gets cancelled, one h bar remains here. So that is equal to, we can write as h star is equal to h bar plus Ig by AH bar we can write. Okay, this is the equation for finding the location of the center of the pressure from the free surface here. Okay, so again you need to remember this is h bar plus, h bar is the center of gravity distance from the free surface. So always here H star lies below the center of gravity, that you have to remember here.